pKa. Okay, and then let's do question number 6. 6 through 9 refer to the following buffer solution. Okay, now we are going to make a buffer solution. Propionic acid. Propionic acid is a weak acid, HC3H5O2, has a Ka value of 1.3 × 10⁻⁵. A buffer solution is prepared by mixing 20 milliliters of 0.1 molar propionic acid with 10 milliliters of 0.1 molar sodium propionate as its conjugate base. So you guys know, for a buffer to make, we need to have acid and also the conjugate base of the same acid. Okay, or you can have a base and also conjugate acid of the base. So in our case, we are using here a propionic acid. So propionic acid is an organic acid. So you guys know acetic acid, right? So acetic acid is this CH3COOH. So this is a carboxylic acid. Carboxylic acid represent this part. When you have COOH group, we call it as a carboxylic acid. So with 2 carbons, it's acetic acid or ethanoic acid, the proper name. And then when you have 1 more carbon, CH3, CH2, COOH, and this is called propionic acid. If you have another carbon, that would be butanoic acid. And then with 5 carbons, pentanoic, hexanoic, heptanoid, octanoid, like that. Okay, so this you will find this information, this kind of acids in organic chemistry too. So this one is a propionic acid. So you see here that first H in propionic acid represent that hydrogen. There are 3 carbons, 1, 2, 3, and then we have 5 hydrogens, 3 plus 2, and then 2 oxygens, these 2 oxygens. Okay, that's the structure of the propionic acid. Now we're going to be making this propionic acid and then the conjugate base of the propionic acid. So the conjugate base, CH3, CH2, CO2H. So this is the propionic acid, and then the conjugate base would be CH3, CH2, COO minus conjugate base. The conjugate base cannot be by itself, so you need to have its counter ion. So this comes as a sodium propionate with sodium ion, like that. Now with these 2 components, we can make a buffer. We have the acid and the conjugate base. Okay. Now how are we going to make this buffer solution? Mixing 20 milliliters of propionic acid. So you have 20 milliliters propionic acid. Molarity is 0.1 molar. And then you have 10 milliliters 0.1 molar sodium propionate. So you mix these 2 together. Okay, so 10 milliliters and 20 milliliters, you mix this together, and then let's say you put it in another beaker. Now what is the volume going to be in this new solution, new buffer solution that you just made? 20 coming from propionic acid, 10 comes from sodium propionate, so the new volume is 30 milliliters. Okay, now we have both buffer components now in this 30 milliliter solution. Why do we need to find out? What is the concentration of the acid component of this buffer solution? Now we made the buffer. This is your buffer. You need to find out what is the concentration of the acid. So this is your acid. How do we make the buffer from the acid? By taking 20 milliliters of the acid with 0.1 molar solution. Now this amount is in 30 milliliters. We need to find out the new concentration of the acid component. How do we do that? Simple. We can use the dilution equation. M1V1 equals M2V2. Right? So you can consider your M1 as 0.1, and then the volume 20. You took 20 milliliters of the acid. M2 we don't know. And then the V2, now the new volume is 30 milliliters. So when you do these calculations, 0.1 times 2 over 30, that will give you the concentration of the buffer solution. Acid component of the buffer solution. What's the answer you're going to be getting when you do? That will be something like 0.0667. Again, check to make sure if I did the calculations correct. Okay, and if I do a mistake, it's your fault. Okay, so the concentration of the acid component of the buffer is going to be 0.0667 molar. Okay, so similarly, the next question is, what is the concentration of the basic component of the buffer solution described in question 6? So now for the basic component also you can use M1V1 equals M2V2. So you can see you use 10 milliliters of 0.1 molar base. Now it is in 30 milliliters. So you can again do the same thing, M1V1 equals M2V2, and then you can calculate the concentration, 0.1 times 10 milliliters, M2 times 30 milliliters. This will give you M2, so 0.1 over 30, that would be 1 over 30. 1 over 30, that will give you 0.0333. That would be the concentration of the base component. Again, check to see if these calculations are correct. And then the next question, what is the hydronium ion concentration in the buffer solution described in the question 6? Remember, the pH of the solution was measured to be 4.59. So now here, the question where it began, it says the pH of this buffer solution is measured to be 4.59. Now we need to find out the hydronium ion concentration. So pH 4.59, how do you find out the hydronium? You know how to find it. pH equals negative log of hydronium ion concentration. So then the hydronium ion concentration would be anti-log of 4.59. Okay, this will give you hydronium ion concentration. Do this calculation in your calculator and find out what is the hydronium ion concentration. That would come something like 2.6 into 10 to the negative 5. Two significant figures, 2.6, 10 to the negative 5. Excuse me. So that's going to be the concentration of hydronium ions. And then the question 9, use your answers to question 6, 7 and 8 and the Henderson-Hasselbalch equation to determine the Ka of propionic acid. So now what is the Henderson-Hasselbalch equation? Excuse me. So the Henderson-Hasselbalch equation is this one. You can find out the pH of a solution by using this equation. pH equals pKa plus log concentration of base, which is the conjugate base, over the concentration of conjugate acid. So we need to find out Ka. But with this equation, first we can find out the pKa. Once you find out the pKa, we know how to calculate the pH. Oh, sorry, the Ka. So pH of this solution was given to us as 4.59. So pH 4.59. We don't know pKa. Plus log concentration of base. Remember, we found the concentration of the base. How did we find it out? Right here. This is the hydronium ions. So question number 7, what is the concentration of basic component? So the base concentration 0.0333, and then conjugate acid. Here from question 6, we calculated the what is the concentration of the conjugate acid component. Okay, and that we found as 0.0667. So we use this information here to find out the pKa by plugging the numbers into Henderson-Hasselbalch equation. So the B, which is going to be the conjugate base, it was 0.0333, and then the acid going to be 0.0667. Okay, first you can perform this calculation. You take 0.0333 divided by 0.0667, and that value you first do this calculation and take that value and then do the log of that number. Okay, so when you do that, you will get an answer 4.59 equals pKa. So this part, first you do the calculation which I have circled without doing any log, and then that answer you get the log of that. That would come to be negative 0.302. Please do the calculation and see if you also get the same number. Okay, so that would be the calculated value you would get for the log of that, negative 0.302. So then the pKa then would be 4.59 plus 0.302, which is going to be 4.89. Okay, so that is the pKa. What we want is the Ka. Again, pKa can be calculated similar to pH. Okay, so pKa equals negative log of Ka, which is similar to pH. pH equals negative log of H3O plus. pKa equals negative log of Ka. So we know pKa. How do you find out the Ka? So then the Ka would be anti-log of 4.89. Okay, so you find out this answer and you write it down as your Ka for the propionic acid, and you will answer that in two significant figures. Okay, so that's how you would do that calculation. Okay, last one. When a few drops of 0.1 molar sodium hydroxide are added to sodium acetic acid, HCH3H5O2. Oh, that's propionic acid. Propionic acid and sodium propionate buffer, the buffer that we were talking about. Now we have made a buffer solution. So you add a few drops of sodium hydroxide, and same buffer that we just described. What will happen to the pH and why? Pick the choice which best answers this question. Now tell me, sodium hydroxide, is it acid or a base? It's a base. So in a basic medium, would the pH go up or down? pH should go up if you add a hydroxide, because this is a basic medium. If you add an acid, pH should go down. So it's going to increase. So we have two choices. First one, decrease, increase, decrease, increase, no change. So we know it's going to increase. Okay, it's going to be either this choice or this choice. Now we have a buffer, 0.1 molar. We are adding few drops of sodium hydroxide. Do you think there would be a dramatic change in the pH of the solution? Let's see. The first choice, the pH, second choice, the pH will increase by less than 0.1 pH unit as the added hydroxide react with the acidic component of the buffer. And then the other one, the pH will increase by less than 0.1 unit as the added hydroxide react with the basic component of the buffer. Now there are two choices. Both choices, first parts are same and they are correct. pH will increase less than 0.1 because it's a buffer region. Buffer is when you add few drops of acid or the base, pH should not change dramatically. Okay. And then which component of the buffer hydroxide ion are going to react? Remember, we have two components in the buffer. It could be either propionic acid, I'm going to abbreviate it as HPR, or it could be the conjugate base. We are adding a hydroxide. Hydroxide ion is a base. Which one do you think is it going to react? Is hydroxide going to react with the conjugate base, or hydroxide going to react with the the acid component of the buffer, which is the acid component of the buffer, right? So then pH will increase less than 0.1, added hydroxide react with the propionic acid component of the buffer, not the conjugate base. So the correct answer choice is going to be this one. Okay, that's all the questions. I hope you understood how to perform the calculations. Talk to you later. Bye bye.